Alright, in this video we're learning how to do the shear diagram and the moment diagram. But before we can even do that, we need to find the reactionary forces at A and B. I don't know if you can see those. So let's find out what forces are at A and what forces are at B. So if we do the summation of the forces, let's do the x first. That must equal 0. So the 6 newtons is going straight down, so it has no x component, so that's 0. B or A can go this way or this way, so it provides no AX component, so AX is 0, so plus 0. B does provide some X component, BX. So if we do a little bit of rearrangement, we just see that BX must equal 0. Now we'll do the same for the summation of the Y components. So they must equal 0. So we don't know what AY is, but we do know that this is 6 newtons plus BY. We don't know what BY is. So then, with a little bit of rearrangement, we get a negative. Actually, that's a negative because it's going down, so that's negative. So we have this negative. Oops. So that's negative. It's going straight down, so this goes over here. So that just turns into 6 newtons must equal AY plus BY. Now, we need to use the summation of the moments to then find out what A and B are related to. So the summation of the moments, and we're going to do the moments around maybe this point. So summation of the moments must equal 0. So we have our 6 newton. We're going to call this force Q. So the moment of Q plus the moment of A plus the moment of B. Q is going straight down to this point. I'm going to change colors. Straight down to that point. Q is. So that's 0 because there's no distance. It has no lever arm. So then that means a negative A moment must equal the moment of B. So this would actually be a negative 9 meters if we have this as our origin. So then the moment of A is equal to the force of A, so AY, so AY is shooting straight up, AY, and again, BY is also shooting straight up, BY. So the moment of A must equal AY negative times a negative 9 meters, and the moment of B must equal BY times 3 meters, and we have that negative A equals a negative B moment. So we'll plug this right there. That would knock out that negative 9. So we have AY times 9 is equal to BY times 3 meters. So then we just divide by, let's say 3. Divide both sides by 3 meters. 3 meters. So then we have 3AY must equal BY. So A is a third of what B is. So I guess instead we can put that's also AY is equal to BY over 3. So now that we have these two separate equations, we can now plug let's plug 3A. Let's use this equation and plug it right there. So now we have our 6 newtons must equal AY plus 3AY because we're plugging in BY. So we're plugging 3AY in for BY. 3AY, and that is just equal to 4AY. So now we have 6 newtons must equal 4AY, and that's 1.5 newtons. So AY is equal to 1.5 newtons. That is, yeah, because 4 times 0.5, 2, so yeah, 1.5 newtons. So we know what AY is. So AY, I guess we can write it over here. AY is equal to 1.5 newtons. And if AY plus BY must equal 6 newtons, so then we just take 6 newtons minus 1.5 newtons, and we get BY, and that just turns out to be 4.5 newtons. So BY is equal to 4.5 newtons. So we now know what A and BY are. Okay. So what does that have to do with shear, the shear diagram and moment diagrams? Well, to get the moment, or I guess let's do shear first. If we broke this in half, broken in half right down here, right there, and we have AY equals 1.5 newtons. I'm just going to write that down here. AY equals 1.5 newtons. BY equals 4.5 newtons. We broke that in half. So let's do the summation of the forces now on just this component. So the summation of the Y forces on this block, and we'll say this is block 1, this is 2. So we have the Y component going up, which is 1.5 newtons, and then there must be some force right here that counters that force. So we have that equals 0, so we have 1.5 newtons plus some other force, V. So then what would V be? We'll say that's V1. So then V1 must equal a negative 1.5 newtons to keep this stationary. Now, if we treated this right here as our origins, and I'm running out of time, so we'll just continue on going. Let's find the shear now at this. Let's find this shear. So let's do the summation of the forces of block 2. They must equal 0. So this is pushing upwards with a force of 4.5 newtons. So to counter that 4.5 newtons, we must apply some force here. So we have V plus V2 plus the 4.5 newtons. So then V2 must equal a negative 4.5 newtons. And I'm going to stop here. And this might be a little bit confusing, but trust me, I'll explain a little bit more in the next video.